Well, hello to absolutely nobody out there. This is my first try at streaming, so yeah, we're gonna see how this goes. Consider it an experiment. Anyway, I was doing something that I thought would be kind of interesting, so I threw together a quick streaming bit for it, and we'll see how it goes. It'll be kind of rusty as I get started here. I don't know if it's rusty because I am not starting from any particular point. So let's see here. No views. Curses. I mean, I put this channel up here, or put this live stream up here 10 seconds ago, and I thought I would have thousands of people joining already, but yeah, I have 0. What a shock. I didn't expect to have any. Well, what we're doing today, let's see how our whole camera setup works out. We have a wonky display for, this is a mouthful, but this is a desk controller, meaning it's one of the automated desks that you can raise and lower the desk height using some button panels here. Now, I've already disassembled the button panel portion. This is JCHT 35K-1 is the model here. JC, I'm quite sure, stands for JieCang, JieChang. What I didn't put up here was a Firefox window, a browser window. That's a shame. So, so that's probably something I should have done, because I'll need a browser up there quite a bit. So let's see how quickly we can do application capture and grab that browser. There we go. All right, we're just going to throw that out there a little bit. It's not quite the right size, but I think it'll be good enough. So yeah, could have put my face in front of it, because that'd be so cool. Let's copy that and put it on the browser one. Hey, there I am. All right, so hopefully that's big enough. Yeah, so this is one of the JieCang. Let's go find it. Let's ask chat how we say JieCang first. JieChang. I think it's JieCang. Chang sounds like Chang. Oh, Chang song. So JieCang. JieCang. All right, that's pretty solid. So let's find them. JieCang controller desk. They have a website, I know. There it is. Manufacturer of standing desk. Oh, CANG. I said JieCang. JieCang. Interesting. All right, so JieCang, and there is somewhere in here is going to be the control box for the desks. And the control box for this one, which let's see if we can find it. I'm going to throw it up here. I need to get my face off that, though, don't I? Let's take my face off that one. All right. I gotta make sure. I hope I'm streaming audio. I wonder how I'd make sure I'm streaming audio. Do I have to add the mic? Warning, the stream something streams. This is cool. There's like no pressure. The stream's current bit rate is lower than the recommended. We recommend that you use 6800 kilobytes per secundo. I wonder how we change the stream rate. Stream health is good. It's good. It's good. How's that? It's good. Let's copy this one. Let's put it on that one and that one. All right, it should be good. I hope it's actually, the audio is working. Stream. I don't really know why all right. Concurrent viewers 1. Is that me? I should presume it's me. All right, so if we go back to this camera here and we look at the actual controller, so this is the control box. This mounts underneath the desk, and the motors plug into some connectors over here. This has 2 motors on it. This is the output to the control, which sits just under the front lip of the desk. And this has power in, and it also has a serial port with a Bizarro connector, just an RJ12, but a Bizarro pinout over here. And this is actually serial also. This is like TTL serial into this one. So we're going to do some troubleshooting. Let's see what this thing is. It's a JCB35N-110. So let's take, I think I've maybe found it already. Let's look at the browser again. JCB35N. There's a lot of 35Ns in here, so maybe not. 35N-110. This is an NH2. Output power 400 watts. And so on. So probably this one's a little old, the one that I've got here. So we might not find that exact same one anymore. But never fear, because I think it's fine. So data sheet. Let's take a look and see what they say about it. Let's get rid of that. Side line groove design. I don't know what that means. 2 columns. Not a lot to share about this. Oh, look at that. Options: 2.4G wireless receive, USB charging, lithium-ion battery case, 400 watts. Some sizes. This is about what my connector set looks like. I have these 2. I do not have this one. I have these 3 on this side, 2 motors and the power, the desktop control thingy, and the serial port that I mentioned just a moment ago. This is exactly what my desk looks like from the top. And there's the model numbers, software code. I don't think I really have a model number as long as that. Input voltage, I do have a 110 in there. Power cord code, line length. I assume that's the length of the power wire, or maybe the motor wires. Stroke. Okay. So that's it for that. Not super helpful, but it's there. So I forgot what I was going to even mention that. Wow. What I did want to say, though, is here's what's wrong with it. So here's the controller, and it actually works really well. This is up and down, and then these are memory 1 through 4, and then this is the M button that you press to store the memory. And there are, I believe, some other features some other things you can do with it, but not really going to do those today because I don't have the motors attached. But what's wrong is that the display is wonky, and it doesn't look that great on the camera. It doesn't look that great at all, but this really helped out a lot to show the wonkiness. So here, if you look, you can see that it should be, I think, 42.1 right now. And I wonder if I hit up right now, if it'll, yeah, so error 07. I wonder if it'll reset itself. Some other error. But you can't really tell what it is because it's not really going to give us a number. So let's power it off. Some capacitors have to discharge. There we go. Let's turn it back on. Oh, bugger. The error is going to stay. So who knows what 6.5 something, I suppose that's supposed to say, but you can see that without the glare, you can definitely see that some of the segments are on dim, like all the 9 and everything there that looks like 9, but it's like these two are on fully, the top and the top left. This left one is not on at all. Even the decimal point is on partially, so that's kind of weird. That's definitely not right. And the interesting part is that when we get into the circuitry, it should be that the same problem is across 3 digits, I think, but it's not. So I'm a little confused as to what's going on with this. So that's why I thought it'd be fun to do as a live stream. Let's go through a little bit about what the circuit is that runs this. So I think I did a schematic of that. And what this uses, it uses a multiplexer. So you have a clock and data line coming to a multiplexer from the controller. And the clock and the data line go to a serial multiplexer. And what's going on is you have a total of 8 segments. You have 7 here in the digit plus a decimal point. So you have 8 different segments. So if you think of an 8-bit byte, that would be 1 byte of information. So somehow what you'd like to do is get 1 byte to show up here. So if, say, A is position 1 in the byte, then if, well, it doesn't really show very well, but if A was this segment up here, then see if we have A, B, C, D. There we go. So A would be position 1 in the byte. B over here would be position 2. C is 3, D, E, F, and G. So we really go clockwise around the digit, A, B, C, D, E, F, and then we do the horizontal bar in the middle of the digit for G, for the 7th bit. And then the 8th one, presumably the 8th one is the decimal point dot over here. So let's just remember A is the top bar. And then we go kind of around the circle. So let's go back to this. And we would have, this is chat, so not quite right. So we have A, B, C, D, and so on. So, well, there's A, B, C. I'm not sure. No, that's not right. All right, so what we've got here is the first bit of the byte should control this one. 2nd bit, 3rd bit, 4th bit, 5th bit, 6th bit, 7th bit, and 8th bit for the decimal point. So if we put a number in here, and that number is, say, 1, binary decimal doesn't matter, hex doesn't matter, that should turn on the least significant digit, which is here. If we put on 0, 1, that would turn on this one. No, if 1, 0, if we put on 1, 0, that would turn on this horizontal bar, which is the 7th bit in the byte, and it would turn off this one, which is the 8th bit. So 0, 1 would do that, and like, you know, and then if you go through, if you just start from the left, you'd have 1, 1, 1, 1, 1, 1, and so on to turn these on. So hopefully that makes sense. In the microcontroller, then we have this, we would be able to represent the digit as a single bit, as a single byte. So then we've got to take that single byte and we've got to get that to correlate to the 8 segments here in this display. That's the first problem. The second problem is how do we determine which of the 3 displays we're going to light up. Now we could have 3 of these multiplexers, but we have a better way shown here. So what we would do, this multiplexer has a data, look at this is wrong, a data input and a clock input. And the data input, once that data is either 0 or 1, once it's stable as 0 or 1, we would fire the clock once. And when we fire the clock once, that would shift whatever data was here would get shifted into the bit. So if the byte is, if you think of the byte as a sequence of boxes, and every time you run the clock, it shifts to the, say, to the right, you're going, whatever the data is when we hit the clock, that data is going to go here. Whatever was here is going to go here. Whatever is here is going to go here, and so on all the way out to the end. And when you get to the last one, it shifts to nowhere. It just disappears. So it's overwritten by whatever was to its left. So each time we do the pulse the clock, that's what we're going to get. So we need to, our software has got to loop through. We've got a lookup table that would say the digit 1 would be B and C. So we got to turn on, say, bit 2 and 3. So if we want to show a 1, which is, I think it's to the right. Is it maybe to the left? I hope it's to the right. So if this is 1, which I think it is, we need the bits 2 and 3 to be on. So the bit code would be 01100000. So whatever that is in hex, and I'd have to pull up my hex calculator to convert decimal to hex. Let's just do that here. So 01100000 convert 60 hex. So we would want 60 hex to be in our lookup table for the digit 1. Super simple to understanding concept. So the next thing we have to do is figure out which of these 3 we're turning on. So this is just a mess. This is not a good schematic. So what should be is that each of the A segments here should all be tied to the A output of this U1. So this one, and this one. The anodes of these 3 would be tied to the output of this multiplexer. So the anodes are all tied together, but the cathodes are not. So what you would do is have each of the three cathodes for each display goes out to one of these transistor circuits. And you've got an NPN transistor out here, and when the controller turns on a particular transistor, it allows current to flow from the cathode down to ground. That's what we want. So whichever one you want to go, all 3 of the anodes have positive voltages on them, but none of the cathodes do. So as soon as we turn on this cathode, or this cathode, the display will go on. So really that's what we've got going on with this multiplexed 3-digit 7-segment display. So you would think if this is ghosting, first off, if this digit isn't on, but some of these others digit segment is on, but some of these other segments are not on, you would think that as the transistors fire, the 3 different transistors cycle through, that error should flip from digit to digit where the same segments are messed up across each of the 3 digits, but it doesn't work that way. It depends on the digit. You would also think that if the display was bad, we could check that, but I already did that. I don't think the display is bad. So is the multiplexer bad? I don't think so, but I already replaced it once and the same problem came back. Are the transistors bad? I don't think so, because I replaced the transistors and the same problem occurred as before. So I'm a little bit confused as to what went wrong with this circuit, and I thought it'd be a good showing for streaming video. Be crazy if somebody was actually paying attention to this. Be like funny. I'd probably be embarrassed, to be honest. It says 2 views. Yeah, I would assume that's me. I should probably take a look. I don't even know where to look for streaming stats and stuff. So, latest video performance. I don't know. Probably shouldn't be doing this. Okay, so back to the topic at hand. Let's go back to this device itself and see what we got going on here. So we already said the display is wonky. If we flip it over, this is the shift register right here. And this behind the display, this is all the circuitry. There are let's zoom in here. I'm going to disconnect this whole thing. And there are 3 transistors. 1, 2, 3. And each of those transistors, the base current is limited by these resistors. There's one, I forgot which one of these. One of these is limiting the base current. And then we have the 8 segments that I mentioned, if you include the decimal as a segment. And then you have current limiting resistors in series with the 8 segments. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then we have our 3 transistors, and here we go, 1, 2, 3, 4, 5, 6, 7, 8 for the current limiters, and then we have the base current limiter 1, 2, 3. I think those are the ones, but it doesn't really matter. This might be a segment, and one of these is base current, but we can look at the values of them to know for sure. So I already replaced these 3 transistors, and I replaced this U2 multiplexer. And neither one solved the problem, which I probably should have guessed, but I already had that. That was easy, and I already had these, so that was easy. I was trying to do this without a scope, without going into the whole oscilloscope thing, but I guess that's where we are, is we're going to have to start looking at signals with an oscilloscope. I am going to end this live stream for now and come back.